Okay, for next question, it's given that a woman weighing 50 kgf stands on a weighing machine placed inside a lift. What will be the reading of the machine when the lift is moving upwards with a uniform velocity of 5 meters per second? So let's consider the first case, and let's say this is the lift, and in the lift there is a weighing machine on which the woman is standing. And in the first case, it's given that it's moving upwards with a uniform velocity of 5 meter per second. So because the velocity is uniform, so that means the acceleration is zero. So because the acceleration is zero, that means there is no pseudo force acting in this case. So the reading of the machine will be the weight of the woman. So in this case, first case, the reading of machine would be the weight of the woman, which is 50 kgf. If it's given that is 50 kgf, and we know that 1 kgf is equal to 9.8 Newton, because 1 kgf is the gravitational unit of force, and that is equal to 1 kg into 9.8 meter per second square. That is when a force of, so it's 1 kgf. The force is said to be 1 kgf when producing an acceleration of 9.8 meter per second square on a body of mass 1 kg. So that is 1 kgf. So in this case, it's asked that we have to take g as 10. So that is 1 kg into 10 meter per second square. So that should be equal to 10 kg meter per second square, and kg meter per second square is Newton, so this is 10 Newton. So if we have to convert this into Newton, so that it has to be multiplied, because 1 kgf is equal to 10 Newton, 50 kgf would be equal to 50 into 10 Newton, so that would be 500 Newton should be the reading. Okay, let's move on to the second case. And in the second case, that it's given that it's moving, lift is moving downwards with the uniform acceleration. Okay, so this is the lift, and it's moving downward with the uniform acceleration of 1 meter per second square. So this is 1 meter per second square, and this is the woman that is standing on a weighing machine. So in this case, the weight is acting downwards. Now, since the acceleration is downwards, so the pseudo force will act upwards. So pseudo force will be m into a, and the reading or the apparent weight of the woman in this case would be mg minus ma. So apparent weight is equal to mg minus ma. So m is the mass. Now how do we find mass? It's given that weight is 50 kgf. So weight is 50 kgf, and weight is m into g, where m is the mass. Now 50 kgf. So 50 kgf should be equal to 50 into the acceleration, that is g. So if we write here g, so g and g gets cancelled, so mass is 50 kg. So let's put the value, replace the value of the mass, which is 50 kg, and the acceleration is given that we have to take it as 10, acceleration due to gravity, and the acceleration with which the lift is moving downwards is 1. So this is 50 into 9, that is 450 Newton should be the apparent weight or the reading of the machine when it's moving downwards with the uniform acceleration of 1 meter per second square. Do like, share, and subscribe. Thank you for watching.